Hello and welcome to Indices 2 with Cubic Education. In this mini lecture we're going to understand negative indices and deal with coefficients, as well as simplifying expressions using the rules of indices that we either already know or that we would have learned in this session. So if you have not watched the first lesson on indices, I suggest you do that first, or if you watched it a while ago, I would recommend recapping with that before going on to this one. So here are the rules that we already know from the first lecture we did on indices. Okay, so this one shows us that when we times numbers together with powers, we add the powers. When we divide, we take away. When they're in brackets, we multiply them. And then the last two special rules is that any number to the power of 0 has an answer of 1, and any number to the power of 1 has an answer of just that number. We don't have to put the 1. Okay, so like I said, recap with the last lecture if you need to. So in this lecture, you're going to learn how to deal with negative powers and how to combine harder expressions using these rules. So, negative indices. We know already that 2 cubed means 2 times 2 times 2, which equals 8. We know that cubed is 3 lots of the 2 times together. Okay, so what do we think that 2 to the minus 3 means, to the power of minus 3? Okay, so it's not the negative version of 2 cubed, it won't be minus 8 or something like that. Alright, what we actually need to do is the minus means that it's a really small number, and actually it's going to be a fraction. So the way that I like to teach this to not confuse you too much is to say that the minus, this minus, in order to be turned into a fraction, we need to get rid of the minus, and that minus is replaced by the 1 on top of the fraction every time. You don't have to worry about why at this stage, just trust me. So to get rid of that minus, we need to start writing a fraction with 1 over the top of the fraction line. And then to decide what goes on the bottom, it's really easy because you've got rid of the minus, so you've taken this minus away, and on the bottom of the fraction, it's just going to be the 2 to the power of 3, which we had before anyway. We just got rid of the minus, okay? So that's all you have to do. If you've got a minus, you get rid of it by writing the 1 over, and then write the rest of it without the minus in. Okay, so 2 cubed, we know what 2 cubed means. It means 8. So it's just going to be 1 over 8 instead. Okay, instead of just being 8 on its own, it's 1 over 8. Alright, because it's a small number. 1/8 is actually like 0.125. It's a really small, or not really small, but it's a small amount of a whole one. Okay, let's look at another example. So if we had 3 cubed, we also know that that means 3 times 3 times 3, which is 27. Obviously, this could be any number. It doesn't have to be cubed. I've just used cubed in my examples. I'm going to show you lots of more examples with lots of different powers. Again, what does the minus 3 actually mean? Well, it means that it's going to be a really small number, and it's not the negative version of 3 cubed. So we are going to take away our minus and turn it into a fraction by putting 1 over, and then we decide what to put on the bottom by looking at our question and seeing that the minus has been taken away, and so we just put the 3 cubed in. Okay, so 1 over 3 cubed, and 3 cubed is actually 27, so 1 over 27. So it's like kind of like the same, but with a fraction, with a 1 over it. Okay, so it's quite easy, it's just getting your head around it. Okay, so a negative, having a negative sign, creates what we call a reciprocal. Okay, the reciprocal of a number is the value you need to multiply by to give an answer of 1. So the reciprocal of 2 is a half, because 2 times a half is 1. The reciprocal of 4 is a quarter, because 4 times a quarter is 1. Okay? So the rule you need to remember here is anything to the minus of a power is going to be 1 over, and then that number to that power without the negative. I really hope that makes sense. If you have any questions, please comment on the video and say that you don't understand something or whatever, or email me privately, that's fine. Don't forget my email is info@cubiceducation.com. So you can ask me any questions if you don't want to post it publicly on the course comments. So what I want you to do now is pause the video and have a go at these ones, see if you can remember what I've just said. Rewrite the expressions using the fractions and the powers, and put them in their simplest form, and then press play for the answers. Okay, if you've had a go, let's go through the answers. So this one, it's just an a, so it'd be 1 over a to the power of 4. Okay, so you're just getting rid of the minus, putting in a 1 over, and putting the same numbers in. Really easy. This next one, 1 over 3 to the power of 7. Get rid of the minus, put in a fraction. This one, 1 over b to the power of 9, 1 over d to the power of 9, and 1 over 7 to the power of 2. Now, I did say write them in their simplest form. I haven't done it for these ones because most of them were letters. This one would obviously be 3 times 3 times 3 times 3. I don't want to work that out right now. And this one's 7 times 7, which is 49. So if you got that one, then well done. Again, we'll go through some more like this. Okay, so what I want you to do now, again, is pause the video and this time go from the fraction back to the negative indices, okay? So try and think about how we got from the negative indices to the fraction and try and do it backwards. Okay, if you pause the video and had a go, this one, you should find this really easy now because all you've got to do is write this but with a minus in it. So p to the minus 8, r to the minus 4, 5 to the minus 3, s to the minus 1. Okay, the reason this is a minus 1 is because remember, when we have a letter or a number, there's like an imaginary 1 here. Okay, so if we get rid of the fraction, there must be a minus 1. And then here, t to the power minus 4. So I hope you understood that and got them all right. I'm sure you did. Well done. Let's just move on to something a little bit trickier. So rewrite these expressions using the fractions, and this time make sure you do write them in their simplest form because I have done it. So have one more go at these ones that are a little bit trickier. Okay, if you've had a go, let's go through the answers. So this one would be 1 over 3 cubed, okay, which then would be 1 over 27. Okay, so 3 times 3 times 3 makes 27. Don't forget to simplify that last bit. And hopefully you understood that you just get rid of the minus, put the 1 over, and then write it without the minus on the bottom. The next one is 1 over 9 to the power of 1, but you can just write that as 1 over 9, remember? You can get rid of that 1, it doesn't mean anything really, unless we're doing a calculation. 1 over 2 to the power of 6, which would give us 1 over 64. 1 over 5 to the power of 2, which would give us 1 over 25. And then this one, 1 over 10 to the power of 8, which is actually like 100 million, okay? All right, so I hope you got that. Don't worry about this one too much if you got not enough zeros or too many zeros. It's basically like you would write 1, 2, 3, 4, 5, 6, 7, and then it's like a 1 and 8 zeros rather than it being 10 and 8 zeros, okay? All right, so we're now going to use these new rules to simplify expressions where there is a coefficient in front of the variable. If you're not sure what a coefficient is, it is basically these big numbers here, okay? We call it the coefficient of x, and it just means it's in front of x, all right? No biggie, okay? It's just a number. So in this case, I want you to simplify 3x to the power of 4 times 2x to the power of 5. And the thing you need to remember is these powers belong to the x. They don't belong to the 2 and the 3. So this x has got a power and this x has got a power. And if you remember from the last video, we can still add those because they both are the power of the same number or letter. Right? These are different, but they don't belong to the power. The x's do. So when we've got something like this, the easiest thing to do first is multiply the coefficients, okay? Multiply the big numbers. So 3 times 2, let's just do that bit first. We'll do this in stages and try and take some nice neat notes so you can come back to it later. So we're going to multiply 3 times 2. 3 times 2 is 6, okay? Then what we're going to do is work out how many powers of x we have. So can you remember the rule when I just said, you know, we work at, when we multiply numbers with powers, we just add them. So all we've got here is x to the power of 4, so I've just taken this little bit, and I'm timesing it by x to the power of 5, which actually gives me x to the power of 9, okay, because I'm just adding 5 plus 4 is 9. So we have this 6, we have this x to the power of 9, and we've simplified everything. There's nothing else I can do. So my actual answer altogether is 6x to the power of 9, okay? I hope you understand that. Right, let's have a go at another one. If you want to pause the video and have a go at it first, please do. I would recommend it. Okay, if you pause the video and had a go, let's see if you got the answer right. So the first thing we do is multiply the coefficients, multiply the big numbers, 4 and 6. 4 times 6 is 24. The reason I'm multiplying is obviously because I have a multiply sign here. Alright, just be careful of that. It could be a divide next time, you never know. Okay, 4 times 6 is 24. Then we work out how many powers of x we have. So I've got x to the power of 2 and x to the power of 8, and I'm multiplying them together. X squared times x to the power of 8 is actually x to the power of 10. We just add the powers, remember. 8 add 2 is 10. So I've got 24 and I've got x to the power of 10. So my entire answer will be 24x to the power of 10. Seems easy, doesn't it? Now that you know how. Okay, let's try another one. So this one we have a division sign. 12a squared divided by 3a to the power of 5. And we do it in exactly the same way, except we have to use the other rules. If you think you know the rules and you want to have a go, please go ahead. Pause the video and I will go through the answer. Okay, let's go through it. So the first thing we do is we are going to divide the coefficients this time. 12 divided by 3, and that's 4. Okay, it's nice and easy, done that bit. And then we work out how many powers of x we have. Okay, when we divide, we actually subtract the powers. So here we've got a squared and a to the power of 5. A squared divided by a to the power of 5, which means we do 2 take away 5. Well, 2 take away 5 gives us minus 3. So we've got this 4 and we've got this a to the power of minus 3. So our actual answer will be 4a to the power of minus 3. Okay. Right. One more. Try this one. Again, pause the video if you want to. Okay, first things first. And I know I go through a lot of examples, but I think that's good because the more examples you do, the quicker you get and the more you understand it. And you also understand the process. Okay, first thing we do is divide the coefficients. 15 divided by 5 is 3. Okay, so that's the first bit. Then we work out how many powers of, well, I've put powers of x, but in this case, it's powers of y. How many powers of y we have. Okay, so we've got y to the power of 5 divided by y to the power of 2, or y squared. 5 take away 2 is 3. So we have this big 3 and we have the y to the power of 3. So it's just 3y to the power of 3. Okay, now something that we do really need to be careful with is when you have something like this. So if you have a coefficient inside a bracket like this. So we've got a coefficient, a big number, inside a bracket with a power of 4 and a power of 3 outside the bracket. Now remember what I said, this power of 4 belongs to the h, okay, so that doesn't matter about this, but this 3 is actually the power of this entire number, or this entire, can't think of the word now, but the 3 belongs to all of this, the power of 3, so you have to be very careful. I'll explain how you do that. Now if we only had one like this, where we just had no coefficient, we had h and no numbers, we'll just do 4 times 3, okay, because that was the rule. When it's in brackets, we just times the powers. So we would end up with h to the power of 12, because 4 times 3 is 12. Okay, however, it's a bit harder when we have a coefficient, okay, the big number in front of the h, remember the coefficient, it's a bit harder when we have that. So you have to be very careful. So everything in the bracket is to the power of 3. Okay, everything in the bracket. But obviously we don't have to worry too much, we can just do it in steps. So first of all, we would do 5 to the power of 3. Okay, 5 to the power of 3. So that means 5 times 5 times 5. Okay, and that's 125. Then we do the h to the power of 4, all to the power of 3. And all you have to do for that one, because of the rule that we went through in the last lecture, is multiply the two powers, 4 times 3. Okay, so 4 times 3 makes 12. Okay, so that actually has h to the power of 12. So now, all we need to do is write it all out. We've got our 125, okay, and we've got our h to the power of 12. Get rid of the brackets. You've worked out what's in the brackets. You don't need them anymore. So it's 125 h to the power of 12. I can understand how that one might have been a bit confusing. Feel free to watch that slide again and kind of get your head around it a little bit. Okay, let's try another one just to practice. So here we've got 6x to the power of 4 to the power of 2. So don't forget, everything in the brackets is to the power of 2. So let's do 6 to the power of 2 first, because it's easiest. We'll just get that big coefficient out of the way. So 6 squared, 6 to the power of 2 is 6 times 6, which is 36. Okay? And then we do the x to the power of 4, or to the power of 2 as well. So like we've already done that bit, we're just going to do this bit. And remember, because of the rule, we can just multiply those together and do 4 times 2. Okay, 4 times 2 is 8. So we are left with x to the power of 8, and then we have the coefficient. I will remind you one more time that the coefficient goes in front of the letter, okay, so which means we would have x to the power of 8 with 36 in front of it. 36x to the power of 8. Oh, gosh, seems like such hard work, doesn't it? But you'll be fine. Have a go at some of these, pause the video, see how you get on. This bottom one gets you using a couple of rules, so just take your time. Okay, if you pause the video and had a go, let's have a look at this one. We have 2 times 1, technically, there's nothing there, but so our number in front will be 2, and then 4 add 8, so 2x to the power of 12. Okay, 3 times 3 is 9, 3 plus minus 7. So again, I will do a video on, or there will be a video in your course on negative numbers, because you definitely need to understand them in a lot of detail. 3 plus minus 7. The reason it's a plus is because we're timesing. And when we have 3 plus minus 7, the minus wins, okay, I like to say. So technically you can just do 3 take away 7, but, you know. So it'd be 9y to the power of minus 4. Okay. 8 divided by 2 is 4. 4 take away 1 is 3, so 4r to the power of 3. Okay. 5 squared is 25. And then we've got the p, and then 9 times 2. So 25p to the power of 18. Now, this last one, I'll do this in stages. I would have done this times first. I would have concentrated on this bit, and then I would have used my answer and divided it by this. So basically, 3 times 4 is 12. So you'd have had 12a to the power of 11, because you've had 8 plus the 3 is 11. So 12a to the power of 11 divided by 2 gives me 6a, and then take away the 3 gives me 8. So 6a to the power of 8. Again, if there's anything that I've gone through too quickly or you're not sure on, just send me a message or comment in the lecture comments, and I will be able to help you with that. Okay, well done. You've worked really hard on that one. That one's really stressful, I think. Thank you so much for using Cubit Education, and I'll see you in your next lecture. Bye.